Okay, CS fundamentals in Python. Here we go. Next step. So I want to talk about conditionals today. Now, conditionals are basically if-then statements. If something is true, in the case of like a Boolean, right, one of the data types we've talked about, if something is true, then we're going to execute a block of code. And one of the key components to if-then statements is the use of comparison operators. Now, if you remember from our previous conversation about operators, we had assignment operators, mathematical operators, we had these iterative operators, and we also had these comparison operators. I think I called them conditional operators at the time because they're used in conditional statements. So that's why particularly I was referring to them as conditional operators. And so we're going to use those conditional operators, those comparison operators, in a lot of our conditional statements. So we want those to be in top of mind, okay? We're also going to talk about what a logical and is, a logical or is, and a logical not is, as well as membership operators in and not in. So let's jump into code and let's see what all this looks like. So here's where we were last time talking about our user input. Go ahead and make another file. We're going to call this conditionals.py, and you're going to get so used to making new Python files. And go ahead and clear your terminal. If you're not in your virtual environment, if your virtual environment's not activated, go ahead and activate that. So the first thing we're going to want to do is we're going to want to declare some variables. So let's do a couple, and we'll do them in list format. If you remember the receipt program we did before, we can do it like this, and we can say, oh, I forgot another comma. Equals 10, 5, and 15, something along those lines. So now we have three variables, x, y, z, and they're equal to 10, 5, and 15. We've declared three variables there, and we've assigned them using the assignment operator three values. Now we want to do some comparisons, and we want to execute some code based on those comparisons. And the primary form of the comparisons is going to be in if statements. So we would say if x is greater than, using that comparison operator, right, y, colon, here we can print some code. So let's go ahead and print, and we'll print a formatted string, an f string, right? We'll say that x is greater than y. So here what we've done is we've declared some variables, x, y, and z. We've done a comparison using a conditional statement if, and then we've run some code after that. Print the f string, x is greater than y. Let's go ahead and see what this looks like. Python 3, conditionals.py. 10 is greater than 5, which is true. Perfect. Now, this is a really good way to control the flow of your program, right? If you want certain things to happen when certain things are true, you use if-then statements. And if you don't want them to happen, then they won't happen. For example, let me show you what I mean. Let's instead change this to be a less than. So if x is less than y, you might logically think that it's going to change what the statement is here or something along those lines, when in fact, all it's going to do now is not do anything, right? Because it does not satisfy the conditional. The if-then statement is not resulting in a true value, then the code's not going to run. So x is not less than y, therefore the code's not going to run. We could write other if statements, right? So let's leave our first statement the way it was, and let's come down here and let's write another if statement. And this time we will say if x is less than y, we want to print a different statement, right? We want to print x is less than y, right? So if this is true, print x is greater than y. If this is true, print x is less than y. Now we can run our program. We're going to get that same result, right? 10 is greater than 5. If we were to change the assignment so that x in this case is 1 and y is 5, right? We've just made that edit. Come back down to the console, run that program again, and now we get 1 is less than 5. So this block of code was called the first time because x was greater than y. This block of code is called the second time because x is less than y. So that's how if statements work. Let's look next at if we want to check user input. So let's go ahead and give our user a little bit of like a math test, right? So we're going to say user answer equals, we're going to use our input function again and give them a prompt. What is 5 plus 5? Question mark, space, space, to give them a little space to answer. Remember, please, that user input produces a string, and a string is actually not that useful for us in terms of checking our response from our user. So we were just talking about a whole bunch of code we can use here to try to check for our user. So let's use our try statement. Let's try and turn our user answer as a number. So we're going to turn our user answer into a number. And we're going to compare that number to what it should be. In this case, we know 5 plus 5 is 10. So we're going to say if user, I should spell user right, user answer as a number, I'm just going to scroll down so I have to retype it every time, equals. Remember, now I want to use the comparison operator for equality as opposed to the assignment operator I just used, right? I'm going to use the comparison operator to check for equality. I'm going to say if this is equal to 10, print correct. Let's go ahead and put that in quotes, give them an exclamation point. If, now I'm going to show you another, how we use another comparison operator. This is the not equal to. So we've seen greater than, less than. We could do greater or equal to, less than or equal to, but we can also use not equal to. And that is an exclamation point and an equal sign, just like that. So if we say it's not equal to 10, print that is incorrect. And now we've got our not equal to. And if you remember from last time, you can't have a try if you don't have an except. In this case, we want to tell our user if they've given us some input that we can't turn into an integer, can't be the answer to this problem, right? We want to tell our user that. So we want to print that is not a valid answer. Okay, let's go ahead and run this and let's see what we get. I am going to, that's okay. We'll just run it. Here we go. 1 is less than 5. We don't care about that, but we are going to answer our question correctly. We got it correct. We'll run it again. Let's answer it incorrectly this time. That is incorrect. And finally, let's give them some non-valid answer. That is not a valid answer. Works perfectly to a T. So you see here, we're using a couple of different methods. We're using our if the equality is true. We're also checking if the equality is not true. Now this, again, as I've said many times before, is not the most efficient way to write this. And I'm going to show you something a little bit more efficient in our next video. But I just want you to get the idea of conditionals down and how conditionals kind of work. I'm sorry, the lighting keeps changing. I've got a bulb that's going in and out. I also want to look at logical and logical or values. So let's assume that we are going to do, let's say, what is the square root of 100? Now, there's actually two possible answers to this, right? There is positive 10 or negative 10, right? So when we want to test our answer, we could test, is it 10, and then do it again, is it negative 10? But if we do that, we're actually going to end up printing correct. We're going to do more tests than we need to do, right? And we're going to write a lot more codes than we want to do, right? We don't need to do that. Instead, what we'd like to do is check, is it 10 or is it negative 10? Because either would be fine. So we can literally write the word or. Now, when you use or, you have to rewrite the entirety of the equality statement. Oh, I wrote equal 10. Negative 10 is what I wanted. The entirety of the equality statement. And then, so or means if this is true or if this is true. So they don't both have to be true. Just one or the other has to be true. The only way we're going to not print correct is if neither of these is true. If it's not 10 and it's not negative 10. So if we were to set up a truth table, let me jump back into our presentation here. And let me go ahead. I'm going to give us a new screen, and we're going to build a truth table for this, okay? Truth table for or, for logical or. So if the first statement is true and the second statement is true, we're going to end up with a true result. If the first statement is true and the second statement is false, we're going to end up with a true result, right? Because it's an or statement. So because the first statement is true, it's just first one or second one, right? If the first statement is false and the second statement is true, we're still going to end up with a true. The only way we end up with a false is if both are false, like that. So that's our truth table for an or statement. Let's go ahead and copy this. Command V. And let's now, so there's our or. Let's now make a truth table for an and, a logical and, so you can see the difference. Now, and is different than or because and is only ever going to trigger. It's only ever going to be true if both are true. Only one has to be false, or both can be false for it to be false. So the way this truth table state changes then is that true is still true. True false is now false because one of them is false, right? The only way it's true is if both of them are true. False true changes to false because, again, one of them is false. They both have to be true to produce a true. And false, they're both false, so the whole thing stays false. So that's the difference between logical and logical or. If we jump back into our coding, that means as long as one of these is true, this should print correct. Now, if we want to fix this statement, we wouldn't use a logical and. Instead, this case, we would use a logical. We wouldn't use logical or. We would actually use a logical and, right? Because we want it to not be equal to 10, and we want it to not be equal to negative 10. All right, let's go ahead and see. Okay, what is the square root of 100? I'm going to put 10. Correct. Great, that works. I'm going to put negative 10. Great, that works. I'm going to put 9. That works. I'm going to put negative 5. That produces the correct response, which is not correct, right? Because negative 5 is not correct. And finally, I'm going to type some nonsense, and it's going to say that is not a valid answer. So I hope you understand what logical and logical or are doing here. To repeat one more time, or is going to be true as long as one of those two pieces is true, and is only going to be true if both are true. One cannot be false, both cannot be false for that to work. Okay, so that is logical and logical or. I want to talk about logical not too. Now, you see me using not equal to here, but there's actually another way we could do this, right? We could, instead of using this not equal to, we could put a not in front of the whole statement and check for equality. So what does this mean? If I put this exclamation point here, this means if user answer as number is equal, and then it negates it. It makes it negative. Although now it's throwing me, doesn't like that statement. Am I not allowed to put parentheses around it? Let's see. Maybe I'm not allowed to put parentheses around just that part. Let's take this out for a second. And let's see if it'll allow me to do this here. Okay. I'm doing it for a different language. It's actually not exclamation point in Python. It's simply the word not. So now we're saying if not equal to 10 and not And then we can write this part again, user as equal -10. So as opposed to writing the exclamation point before the equal sign, using the not equal to operator, now we're using the logical not operator to say we don't want it equal to 10. We don't want it equal to -10, as opposed to we want it not equal to 10. We want it not equal to -10. It's a subtle change, and in this particular case, it actually doesn't make any difference on the coding, but it does make a difference in terms of our understanding when we can use a not versus a not equal to. A not is a good thing to use when we're dealing with a variable, particularly that we want logically to be true, but we want to continue doing something when it's not true. You saw this before because we actually wrote a while loop. So let's do that now. Let's say let's make a user was correct. Let me show you what I mean here. False. We're going to set this false. User was correct is going to be set false. When the user gets a correct answer, we're going to set user was correct. Hold on one second. I started a new terminal down here. I didn't want to start. Okay. User was correct is going to equal true. This is going to allow us, like our guessing game, to do this game over and over and over again. So while not user was correct. Here we're using the not operator again to say while this value is not true, right? While this value remains false, continue looping through all of this code. Now you've got to indent all this code now because now it's all part of this big while loop. And I know we haven't talked a lot about while loops yet. We will talk more about loops in a second. I just want to show you kind of what some use for not might be. And this is one. We had it in our guessing game too if you want to go back and look at that code. And then let's go ahead and import OS up here so we can do a little screen clearing while we're working. So every time this loops, let's go ahead and clear the screen. Actually, we're going to need to loop this too. So let's go ahead. I'm going to cut this from here. I'm going to put that inside of our loop because we're going to need to loop that as well. We need to get the input every time we loop, right? Oh, and I want to clear the screen. So I'm going to say os.system. I wonder if you remember what we have to do here. We're getting used to writing this over and over again. And remember, if you're on Windows, you're going to use CLS instead of clear. Okay, let's go ahead and run our program. What is the square root of 100? It's 9, right? That is incorrect now. Interestingly enough, because we cleared here, that cleared our that is incorrect really fast, which is not ideal. So let's actually clear after our input. And that way it'll keep, while we're doing our next input, it'll keep. Go ahead and enter 10 to get out of it, and then let's just run it again. Okay, so I'm going to say 9. That is incorrect. What's the square root of 100? I'm going to say -9. That is incorrect. What's the square root of 100? I'm going to say 10. Correct. And we're out of our loop. Our loop has stopped. Why is our loop stopped? Because user was correct was set to true, and we only want this loop running while user was correct is negated, is not true, right? So we have that not. So that's a common use for the logical not. So we talked about logical or, logical and logical not. I also want to talk about a membership conditional. And this is actually a really nifty thing in Python, and it's available in other languages. I don't mean to say it's not, but it's pretty nifty and clean looking in Python. So let's do something a little bit different here. Come down after our program and let's give ourselves a word. Let's give ourselves a string. So we're going to say some word equals the word bear, let's say. Okay. We can test to see if something is a member of this string. And a member just means, is it in there, right? Is it in there? So if B in some word print. Oh, this has to be in quotes. If B in some word, print some word dot find. And if you remember from our discussion about strings, what dot find does, dot find will return an index of where that occurs in our string. So if B is in our some word, if the letter B is in this string some word, right, and in here is doing the work of sort of testing and returning a true or false, it's going to print out the index of that B. So I'm going to answer my question here. Okay, and it prints out 0, right? B is the first in that word. Let's do another one, because we can also use our logical not operator here. If B essentially testing for the opposite of membership, right? Not in some word. Print there is no B in in this word. Okay. And then we could change this from being bear to being pig, right? There's no B in pig. I'm also going to just go ahead and take out our, just for our purposes, so that we don't have to play our guessing game before we get to see our membership test here. Okay. Run that code. There is no B in this word. And what would be interesting is you could use this logic if you wanted to make a pretty effective hangman game, let's say, right? Where it picked a word randomly from a set of words. I can show you how to do that a little bit later. But then your user could input a letter, and you could use the membership conditional to test, is that letter in the word? And if so, add it to the screen. Or if it's not, add a body part to the hangman and reduce the number of guesses that your user has. Okay, a lot of information on that, on conditionals, but conditionals are going to be a really important and big part of how we build our programs. So I hope you found that helpful and informative. Take your time, go over, play with them a little bit, play with the code we've written today, and see what changes happen when you change and mess around with the conditionals. And that'll be it for now.